All right, ladies and gentlemen, in this video, I'm going to go over how to model equation. All right, let's take a look at the first problem. The first problem says x plus 3 equals 5. Whenever we're modeling, we're going to have different pictures that are going to represent our variable and different pictures that are going to represent our unit values. So in this case, x is equal to a long bar and 1 is equal to a small square. So now we're going to go ahead and set up the equation with that information. So the first part here says x, so that means I'm going to need 1 bar plus 3 units. So that's going to be 3 of these squares here. So 1, 2, and 3. And that's all going to equal 5. So I need 5 single units again. So that's 1, 2, 3, 4, and 1 more makes 5. Okay, so we have our equation here. We have 1x plus 3 units equals 5 single units. Now, if we're going to solve this, we want to see what is it that we can do to the left side for it to still equal the right-hand side. Because remember, with equations, the whole point is to keep it balanced. Now, we just want to know how much x is, or how much this bar is. But we can't tell that when we have these 3 units over here next to it. So we're going to need to get rid of those 3 units. And if we do, in order to keep it balanced, whatever we do to one side, we have to do to the other. So to get this bar by itself, I'm going to take away 1 from here, which means I need to take away 1 from the right-hand side. I still need to take away 1 from the left, and so that means I have to take 1 away from the right. I still have 1 more on the left, so then I'm going to take 1 more away from the right. So what this tells us is that 1 bar, which is x, is equal to 2 units, 1, 2. And if we were to solve that like normal, we would say x is attached to a plus 3, so we would subtract 3. Whatever we do to one side, we have to do to the other. These 3's end up canceling. We bring down our x, and 5 minus 3 is 2. And that's exactly what we have here. Okay, let's take a look at the next problem. We have x plus 1 equals 3. So again, our key, we have x is equal to a long bar, and 1 single unit is equal to a single square. So I'm going to go ahead and model this equation. So we have 1 single x here, so that means I need 1 single bar, plus 1 single unit. So that would be one of these squares. And that is going to be equal to, let me put my equal sign there, 3 single units. So I'm going to need 3 of these. So that's 1, 2, and 3. Okay, so to solve this balance, remember whatever we do to one side, we have to do to the other. Our main goal is to get this bar all by itself, but if you notice, we've got this single one that's attached here, so we want to get rid of that. And if we do get rid of it, whatever we do to one side, we have to do to the other. So I'm going to get rid of this one on the left, and whatever you do to the left, you have to do to the right. So I'm going to get rid of 1 on the right. So here, our answer is going to say 1 bar is equal to 2 squares, and that means that x would be equal to 2. Well, let's test that out by doing the math real quick. In order to solve this, the opposite of adding 1 would be subtracting 1. Whatever you do to one side, you do to the other. So I'm going to subtract 1 here as well. Our 1's cancel. I'm going to bring down x, and 3 minus 1 is 2. Now let's take a look at this equation. We still have our key here with 1 bar equaling x and 1 square equaling 1. But this time they want us to write an equation. So if we have 1 single bar here, that would be representing x. And notice there are 1, 2, 3, 4, 5 single little boxes added to it. So we're going to say plus 5 equals, and then there's 1, 2, 3, 4, 5, 6 single little boxes here. So we're going to say equals 6. So when we're writing an equation, we just look to see how many bars we have. And then if there's anything attached to it, we would add it. So plus 1, 2, 3, 4, 5. And that equals to our 6 little units. So x plus 5 equals 6 would be our equation. For our next problem, it wants us to write an equation again. We have the same key, 1 bar equals x and 1 square equals a single unit. If we look here, we have 1 bar, so that means we would have 1 single x. And there's 1, 2, 3, 4 single units attached, so they added 4 single units to it. Equals, and on the right hand side we have 1, 2, 3, 4, 5, 6, 7 units. So our equation for this would be x plus 4 equals 7 units. For this problem, we're going to kind of switch gears a little bit. This one says 2x equals 8. Remember, when the numbers are next to each other, or I'm sorry, the coefficient and the variable are next to each other, that means multiplication. So this is going to be a little bit different from those addition problems that we were looking at. So for here, it says 2x equals 8. So that means we need to have 2 x's. In other words, 2 bars. So I'm going to go ahead and select 2 bars. 1 and 2. So now we have 2 x's. Notice it says 2x, so we have 2 bars. And that's going to equal 8 single units. So I'm going to need 8 of these units. So that's 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so now we've got our 2 bars, which means 2 x's, equals an 8 single units here. Now, we want to just know how much 1 bar is, not how many 2 bars are. Now, usually we would take away from one side and take away from the other side, but here it's a little bit different. If I take away a bar here, there's no other bar to take away from on the other side. So we're going to have to think about things a little bit differently. I noticed that we have 2 bars here and 8 units over here. How many units do you think would equal 1 bar? Well, if we look at that, if we have 2, then that means we're going to need to split it in half to see. So if we have 1 bar here and 1 bar here, if we just split that in half, we can figure out how many units each bar is worth. So if this bar here gets 1, this bar gets 1. If this bar gets 1, this bar gets 1. If this bar gets 1, that bar gets 1. And if this bar gets 1, that bar gets 1. So in other words, 1 bar is going to be equal to 4 units. So each bar is going to end up with 4 units. So that's how you solve those multiplication type problems. And we can always double check. Remember, the opposite of multiplying is dividing, so we would divide by 2 on both sides. The 2's would cancel. We bring down our x, and 2 can go into 8 4 times. And again, 1 bar is equal to 4 units. For this problem, we have 6 is equal to 3x. So here they started off with 6 single units, so I'm going to go ahead and create that. So that's 1, 2, 3, 4, 5, and 6. And that's going to be equal to 3x. So because it's equal to 3x, that means I need 3 of these bars. So that creates 1, 2, and 3 bars. So just like we did before, we can't take away a bar from both sides, or we can't take away a single unit from both sides because there aren't on both sides. So what we're going to have to do is figure out how much each bar is worth. So we're going to basically divide it evenly. So how much do you think each bar is going to be worth if we split it perfectly? If we did, that means this bar would get 1, this bar would get 1, and this bar would get 1. And doing it again, this bar gets 1, this bar gets 1, and this bar gets 1. So that means each bar is getting 2 units. So that means that 1 bar would equal 2 units. Now let's go ahead and double check that with solving this equation. Here's our variable. Attached to it is a multiplication of 3. To undo a multiplication of 3, you need to divide by 3. Whatever you do to one side, you have to do to the other. These 3's will cancel, giving us x equals, and 6 divided by 3 is 2. So again, 1 bar is equal to 2 units. For this problem, they want us to write an equation. So our key is the same, 1 bar is x, and 1 single square is 1 unit. So notice we have 1, 2, 3, 4 bars, which means we have 1, 2, 3, 4 x's. So I'm going to write 4x equals, and then over here we've got 1, 2, 3, 4 single units, so that would be a 4. And again, if we wanted to solve this, we could divide both sides by 4, and each bar would end up with 1 box. For the last problem, it asks us to write an equation again. So for this one, we have 1 bar equaling x, and we've got 1, 2, 3. So that's 3 x's equals, and then we just need to figure out how many singles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it equals 12. So then we would just need to figure out how much each bar would get, and we could do that by dividing by 3. If we put these into 3 groups, then we would end up with 1 bar equaling 4. So this is how you model equations with your multiplying and your adding.